Assalamu alaikum. For today's topic is dispersion of white light and its cause. First of all, we should define dispersion. What is dispersion of light? When a narrow beam of sunlight is incident on a glass prism, when a narrow beam of sunlight is incident on a glass prism, the emergent light, the light which comes out through the prism, the emergent light, when made to fall on a screen shows seven colored bands, shows seven colored bands. This is called dispersion of light. Yes, yeah, simply we can say the phenomenon of splitting of white light into its constant colors when passing through a glass prism is called dispersion of light. Broadly, the component colors are in sequence. They are in the sequence. First color which we observe, that is, we can write also the view over, that is V stands for violet. V is equal to violet. I stands for indigo. B stands for blue. G stands for green. Y stands for yellow. O stands for orange. R stands for red. That means if we look here, suppose this is the prism, principal section of the prism. Okay, white light is falling on it. Here white light is falling on it. When it passes through a glass prism, it is a glass prism, it gets spilled into, suppose we take here, it is a screen here, screen, we will see here बैंड ऑफ कलर्स, ऊपर से हम रेड, फिर ऑरेंज, येलो, फिर ग्रीन, जी फॉर ग्रीन, फिर ब्लू, फिर इंडिगो, ये लास्ट में वायलेट. That means when white light is passed through a prism, the emergent light, when falls on the screen, it shows the band of seven colors. This splitting of white light into constant colors is called dispersion of light. The phenomena of splitting of white light into its component colors on passing through a refracting medium is called dispersion of light. The pattern of colored bands obtained in the screen is called a spectrum. This band is called a spectrum. Now we will see what are the causes of dissonance. When white light is falling on it, how it gets separated. We can now see what are the cause of dispersion of light. Dispersion of light. One scientist has given an important relation that we know that each color is having different wavelength. Suppose if I write here wavelength of different colors. सबसे कम wavelength है violet की. If I write in the angstroms, it is 4000 angstrom white violet की. फिर इंडिको की 4500 angstroms. Blue की 4800 angstroms. We can convert also in meters because we can convert it into meters also. ग्रीन की 5400 एंगस्ट्रॉम्स की. ग्रीन येलो की 5800 एंगस्ट्रॉम्स इसकी है. 6000 इसका है. इसका रेड कलर 7900. Yet some books write 8000 angstrom. That means different colors are in different wavelengths. That means, but red is having the larger wavelength as compared to violet. Violet having least. We know that the refractive index of a material of wavelength lambda is given by Cauchy's relation. By Cauchy's relation, he gave a relation between the refractive index and the wavelength. According to UCHY Cauchy's relation, refractive index is equal to A plus B lambda square plus C lambda raised power 4 plus and so on, where A, B and C are constant. Here we show the relation shows that refractive index of the material depends wavelengths of the light incident on it. That means the refractive index depends upon the wavelength. That is, in other words, refractive index is inversely proportional to 1 by lambda square. We can take it from the relation. Refractive index is inversely proportional to lambda square. That means where wavelength is least, where the color having maximum wavelength having small refractive index. That means wavelength of different colors is different, because these different colors are having different wavelengths. The red color has maximum wavelength while violet has minimum wavelength. We know that red has maximum wavelength. That means wavelength of red is greater than wavelength of violet. We can say because violet is having least wavelength. Red case 7900 because when the wavelength of red is more than that means we can say they are having inverse relation. We can say refractive index of red is less than violet, which implies इसका मतलब ये हो गया refractive index of red is less than refractive index of violet, because from this relation there is an inverse relation between the refractive index and the wavelength here. That which indicates we know that refractive index of red is greater than refractive index of violet, but they are having inverse relation, which indicates इसका ये मतलब हो गया refractive index of red is less than refractive index of violet. If we have already derived the relation, mu for red is less, that means now deviation produced by small angular prism. If you remember deviation produced by small angular that is called mu minus 1 into A. If you remember this relation, I have also solved this equation in previous class. I have proved this deviation for small angular prism is equal to mu minus 1 multiplied by A. Now here deviation produced by red is equal to mu of red minus 1 into A. Okay, deviation produced by violet is equal to mu of V minus 1 into A. But we know that mu of red is less than, that means mu of red, it depends upon mu R and mu V. That means, but mu of red is, refractive index of red is less than refractive index of mu. That means deviation produced by red, which this indicates that deviation produced by red is less than the deviation produced of violet. That means similarly other colors. That means the maximum deviation was produced by violet color and the least deviation is produced by red color. That is why it gets. I hope you have got it. That means what is the cause of dispersion of light, how it becomes a band of spectrum here, how it becomes the band of 7 colors here. because when white light falls on it, it gets split into 7 colors. What is the cause of splitting? Because it depends upon the wavelength. Since different colors have different wavelengths, we know that red is having the maximum wavelength 7900 angstrom, and violet is having the least 4000. From Cauchy's relation, we should know that lambda is equal to a plus b by lambda square plus c by lambda raised by 4 plus say on, where a, b, c and constant. Here we simply say that lambda is inversely proportional, refracting index is inversely proportional to lambda square. That means the refracting index is inversely proportional to lambda. Lambda is the wavelength, but we know that if that means color having maximum wavelength, having less refracting index. But we know that refracting index wavelength of red is more than wavelength of violet. Why we can take these two? Because these are two extreme colors. That is why we are taking these two colors. That means which indicates that refracting index of red is less than refracting index of violet. From minimum deviation proved by small angular prism, we know that relation delta is equal to mu minus 1 into a. That means mu r is equal to refractance of red, deviation of red is equal to mu r minus 1 into a. Deviation of violet is equal to mu v minus this. But it depends upon mu r and mu v. But mu v is less as compared to that. Means deviation produced by red is less as compared to violet, and other colors deviate as per the wavelength. That is why we have seen the band of spectrum here, colors of spectrum, because they show that red color deviates least and violet color deviates the most. The other colors suffers deviation between red and violet because they have the wavelength between red and violet. I hope you have got it. You can see from this also the deviation, it is clear here. I hope you have got this. This is the white light. It is a glass prism, and this supports a deviation here. Why it supports a deviation? Because of different wavelengths. Which are different being the the beam of light which is having larger this wavelength will suffer minimum deviation, while the violet is having the less this wavelength, it suffers the maximum deviation. The other colors suffers the deviation between red and violet. I hope you have got it. Inshallah, we will meet in the next class. We will see the angular dispersion. Thank you very much.